Hi everyone, my name is Meg Souza. This paper that I will present is part of my master's research done with the members of NOLAB, Digital Modeling Laboratory at the Federal University of Viçosa, Brazil. And the title we chose was the Operationalization of a Pattern Language by using network analysis tools. One of the most significant public space studies, a pattern language published in 1977, is until today's background for some contemporary investigations. The book appeared in the middle of criticism about modernist architecture and urban planning, questioned in the 1960s and the 1970s, also by authors such as John Jacobs and William White. Pursuing to interpret user desires and promote a dialogue between professionals and lay people in participatory processes, the work sought to identify timeless characteristics of the space conformation, construction, and rescue the local scale between people. A pattern language is an attempt to reveal and demystify social spatial considerations through organized design patterns for easy consultation and, above all, to show the interconnection of these patterns in a system. Patterns presentation follows a uniform order and organization. The book presents a set of 253 patterns organized in three classes: towns, building, and construction. First, the pattern number, name, and asterisk are presented, indicate its reliability, that is, how the problem solution describes the deep and inevitable properties of a well-shaped environment. In sequence, in some patterns, a photo appears to illustrate how it works in a real situation. The text is divided in two parts. Initially, the interconnected patterns that form the grounds for it to happen are presented. That is, the larger patterns with a broader scope. In sequence, there is a paragraph that best summarizes the problem. In the text box, the characteristics, restrictions, and relations with some patterns are detailed. Below, another highlighted paragraph describes the problem solution, and some even have synthesis diagrams. In the end, the smaller patterns are presented, secondary patterns that complement the described pattern. These characteristics of the relation between larger patterns and small patterns can be represented mathematically by sets. As well as it has been defended and discussed over the years, the book has also been widely criticized. But even in the face of criticism already presented, there is a considerable number of current researchers committed to understanding and inserting it in a digital environment. The methodology of this paper seeks to insert the pattern in network analysis tool and to identify more important and connected patterns. The networks have a visual and intuitive quality capable of extracting some functional groups from a complex system, and it's important to highlight some mathematical concepts inherent in this program's operation logic, such as theories of networks, systems, sets, or graphs. Mathematically, two non-empty sets form a graph, one with nodes and another with edges. We can represent it in different ways: vertex diagrams, adjacency list, and set of diagrams or adjacency matrix. The first challenge of network analysis is to transform data into representation. When we change the relation into a network representation, mathematical information must be passed on. Therefore, it is necessary to identify which kinds of data we will represent because they should be a distinct set of entities and relations between them. The step of data visualization, there are some layout algorithms to help us. However, it's important to emphasize that the central position of nodes into a layout algorithm should not be confused with centrality metrics. The most important motivation in using network analytical methods are modeling and analyzing the probability of indirect effects between nodes, as the direct effects could only be evaluated by basic statistics. The notions of distance are fundamental, as they are measured between pairs of nodes and results in a single number. Beyond distance, other important measures are centrality ones, which measure the dominance of single nodes of the nodes that assume greater importance in the network. The most common centrality measures are degree centrality, betweenness centrality, and closeness centrality, but there are still other metrics such as eigenvector, current flow, and others. The degree analysis considers the direction in which the connections are made and generates three types of ranking: degree, in degree, and out degree. This operationalization follows some instructions from the beginning of the book A Pattern Language. The authors indicate the user should choose an initial pattern that best describes the overall scope of the project in mind. In the sequence, we suggested a list of patterns based on this scope, but only those that describe something possible to achieve should be included. In this methodology, these are the design patterns DP. After the final list of design patterns, the next step is to analyze them individually and identify the connections established in each of them. With larger and smaller patterns are connected. The larger patterns of each one represent the existing conditions that pattern can complement, and in this methodology, they will be classified as context patterns. We converted the connection matrix in two tables, one that contains the nodes and the other that contains the connections already identified considering the directions of the relations. We inserted these two tables in the network analysis software and can be manipulated initially by layout algorithms and color assignment for better visualization. The real situation chosen was an urban intervention carried out in a district of Viçosa, a small town in the state of Minas Gerais in Brazil. The district is located about 8 kilometers from the city center, with approximately 6,000 inhabitants. As a scope, we focused the intervention in an area of 300 meters selected through georeference data and the analysis of segments based on space syntax theory. After we selected the initial pattern and the intervention area, the next step was the selection of the list of design patterns. All of these patterns are consistent with the local context of the 300 diameter and with the possibilities of the research group as a stakeholder. We haven't inserted new patterns, but we adapted the 161 sunny space pattern as it does not match the city weather's reality and changed it to 161 shaded space. In this paper, the software chosen for the analysis was Gephi. Starting from these 32 selected design patterns, we developed the connection matrix as well as the application of filters for the respective context and design patterns. After generating the basic of unitary metrics of distance, diameter, and density, we applied the metrics of out degree centrality together with the context and design classes highlighted by different colors. The design patterns with the highest out degree, that is, those that have to complement the pre-existence of this 300 meters identifiable neighborhood were seed spots and sitting wall. They were evidenced with the representation of the node in a larger size. In the sequence, some patterns with a high ranking or out degree: soft tile and bricks, ornament, canvas roofs, garden seat, warm colors, front door bench, filtered light, and trellised walk. Discussions. The patterns with the best ranking showed by the network analysis are related to the sitting public space behavior, which can indicate two pieces of evidence. The first one is that the patterns network also showed the nature of the project extracted from the book and that they are not based on a simple element, such as a bench, but on all the relations that may arise. Another evidence is that the patterns with the greatest ranking are almost all in the same scale of intervention, which means they are consistent with what the neighborhood offers at the place and the possibilities that directors and stakeholders have to intervene there. They are patterns that connect and do not function as isolated elements. For example, they can be benches associated with ornaments and edges of buildings, or even gardens with a trellised walk and filtered light. What further reinforced the importance of the relation between patterns with the same value degree in more complex networks. This work is funded by FAPEMIG, Fundação de Amparo à Pesquisa de Minas Gerais, and we thank the institution for their support. Thank you all.